Hello friends, welcome to this video. In today's digital age, computing is an integral part of our life. From smartphone to supercomputers, computing paradigms have shaped the way we live, interact and work. In this video, we will take a journey through different computing paradigms. First, what do you mean by a computing paradigm? A computing paradigm refers to the fundamental approach or model for performing computation, organizing data, designing systems of higher levels, and solving problems using computers. Here is the evolution of different computing paradigms. Computing paradigm has been progressed from mainframe computing, then PC computing, network computing, internet computing, grid computing, finally to the cloud computing. Now we are discussing the characteristics of computing paradigm. It includes the principal techniques, methodologies, methodologies. Next, the characteristics of computing paradigms. It includes the principles, techniques, methodologies, and architecture that guide the design, development, and deployment of the computational systems. Computing paradigms can vary widely based on the factors such as underlying hardware, programming models, and problem solving strategies. Each computing paradigm offers different advantages, trade offs, and suitable for specific types of problems and applications. Now, high performance computing paradigms solves complex problems and performs data intensive tasks at high speed. Different paradigms arise from various methodologies, principles, and technologies. Each paradigm has strength, weakness, and specific use cases. Let's discuss each in detail. First of all, what is distributed computing? Distributed computing refers to a system where processing and data storage is distributed across multiple devices or systems rather than being handled by a single central device. In a distributed system, each device or system has its own processing capabilities and may also store and manage its own data. These devices or systems work together to perform tasks and share resources with no single device service as the central hub. Now, the components. The components of distributed computing, devices or systems, network, and resource management. First, devices or systems. The devices or system in a distributed system have their own processing capabilities and may also store and manage their own data. Network. The network connects the devices or systems in the distributed system, allowing them to communicate and exchange data. Resource management. Distributed systems often have some type of resource management system in place to allocate and manage shared resources such as computing power, storage, and networking. Advantages and disadvantages of distributed computing. Advantages: scalability, reliability, flexibility. Scalability. Distributed systems are generally more scalable than the centralized systems, as they can easily add new devices or systems to the network to increase processing and storage capacity. Reliability. Distributed systems are often more reliable than the centralized system, as they can continue to operate even if one of the devices fail. Flexibility. Distributed systems are generally more flexible than the centralized systems, as they can configure and reconfigure more easily to meet changing computing needs. Now, there are few limitations to the distributed computing systems. They are complexity, security issue, and the performance. Complexity. Distributed systems can be more complex than centralized systems, as they involve multiple devices or systems that need to be coordinated and managed. Security. It can be more challenging to secure a distributed system, as security measures must be implemented on each device or system to ensure that the security of the entire system. Now, the performance. Distributed systems may not offer the same level of performance as centralized systems, as processing and data storage distributed across the multiple devices or systems. Now, its applications. Distributed computing system has a number of applications. Few are included here. Cloud computing. Cloud computing systems are a type of distributed computing system that are used to deliver resources such as computing power, storage, and networking over the internet. Peer-to-peer networks. Peer-to-peer networks are a type of distributed computing systems that used to share resources such as files and computing power among the users. Here is the architecture of the distributed computing. Here, each of the devices or the systems in the distributed environment have its own memory and the processor. Now, we are going to discuss the grid computing. Grid computing. What is grid computing? Grid computing can be defined as a network of computers working together to perform a task that would be rather than be difficult for a single machine. All machines on that network work under the same protocol to act as a virtual supercomputer. Why the grid computing is important? Because of its scalable nature, resource utilization, and the complex problem solving and collaboration and cost saving. Scalability. Dynamically scale computational resources to match workload demands. Now, resource utilization. Maximize resource utilization by pooling resources from multiple computers. Complex problem solving. Tackle large scale problems requiring significant computational power. Collaboration. Facilitate global collaborations on shared project. Cost saving. Reuse existing hardware and access excess computational resources. Working of a grid computing. A grid computing network mainly consists of these three types of machines: a control node, and a provider, and a user. The control node, a computer, usually a server or a group of servers which administrate the whole network and keeps the account of all the resources in the network pool. Provider, the computer contributes its resources to the network resource pool. User, the computer that uses the resources on the network. There are mainly three types of grid computing. First, computational grid, then scavenging grid, then data grid. Computational grid, high performance processors for resource intensive tasks. Example, mathematical calculation. Now, scavenging grid utilizes available computing resources from a network of conventional computers. Then data grid. Connect the multiple computers for massive data storage and access regardless of physical location. The use cases or the application of grid computing. Drug discovery, cancer research, weather forecasting, risk analysis, computer aided design, animation and visual effect, collaborate projects. Here is the basic structure or representation of a grid computing. There is a control node, the user, and the provider. Now, the advantage and disadvantages of grid computing. Advantages: coordination and management of cross-device processes and tasks, cost-effective scaling of business processes through coupled computing power and storage capacities, simultaneous or parallel processing, analysis and presentation of large amount of data through global computer networks. Complex tasks can be solved faster and more effectively. No need for large investment in server infrastructure. Now, that is advantages. Complex administration and incompatible system components can occur. Computing power does not increase linearly with the number of coupled computers. Next, the cluster computing. First, what is cluster computing? Cluster computing is a collection of tightly or loosely connected computers that work together so that they can act as a single entity. The connected computers execute operations all together, thus creating the idea of a single machine. The clusters are generally connected to the fast local area networks. Why they are important? Cluster computing gives a relatively inexpensive, unconventional to the large server or mainframe computing solutions. It resolves the demand for content critically and process services in faster way. Many organizations and IT companies are implementing cluster computing to augment their scalability, availability, processing speed and resource management at economic prices. It ensures that the computational power is always available. Then, types of cluster computing. First, high performance clusters, then load balancing clusters and high availability clusters. First, the high performance HP clusters. HP clusters use computers clusters and supercomputers to solve advanced computational problems. They are used to performing functions that need nodes to communicate as they perform their jobs. They are designed to take benefits of parallel processing power of several nodes. The load sharing clusters. Next one is the load sharing clusters. Incoming requests are distributed for resources among several nodes running similar programs or having similar content. This prevents any single node from receiving a disproportionate amount of tasks. This type of distribution is generally used in web hosting environment. Then, high availability clusters. HA clusters are designed to maintain redundant nodes that can act as backup systems in case of any failure occurs. Consistent computing services like business activities, complicated databases, customer services like e-websites and network file distributions are provided. They are designed to give uninterrupted data availability to the customers. Classification of clusters. Open cluster, closed cluster. Open cluster. IPs are needed by every node and those are accessed only through the internet over. This type of cluster causes enhanced security concerns. Then the closed cluster. The nodes are hidden behind the gateway node and they provide increased protection. They need fewer IP addresses and are good for computational tasks. Cluster computing architecture. It is designed with an array of interconnected individual computers and the computer systems operating collectively as a single standalone system is a group of workstations or computers working together as a single integrated computing resources connected by high-speed interconnections. Advantages of cluster computing. High performance, easy to manage, scalable, expandability, availability, then the flexibility. High performance, the systems offer better and enhanced performance than that of the mainframe computing networks. Easy to manage. Cluster computing in manageable and easy to implement. Scalable. Resources can be added to the clusters accordingly. Expandability. Computer clusters can be expanded easily by adding additional computers to the network. Availability. The other nodes will be active when one node gets failed and function as a proxy for the failed node. Flexibility. It can be upgraded to the superior specification or additional nodes can be added. The disadvantages. High cost, problem in finding fault, more space is needed. These were the disadvantages. Applications of cluster computing. Various complex computational problems can be solved using the cluster computing. It can be used in applications of aerodynamics, astrophysics, and in data mining. weather forecasting, image rendering, various e-commerce applications, earthquake simulations, petroleum reservoir simulation. These are other applications of cluster computing. This is a representation of cluster computing. That means all the systems in the cluster is connected to each other. So the systems can work with maximum efficiency. Utility computing. Utility computing refers to the utility computing technologies and the business models that are offered by a service provider to IT customers. The client is charged as per their consumption. Examples of these IT services are storage, computational power, and the applications. Utility computing is similar to the virtualization and the total web storage space amount, with the computing power that is made available to the user is higher than as compared to a single time sharing computer. The web service is possible through several bikes. Now, the advantages and disadvantages. Advantages. The customer does not have to buy the software, hardware, and licenses that are required to do the business. He instead relies on a provider for the services. The client also is not burdened with administrating and maintaining the system, which is taken care of by the utility computing company. The company has the liberty to subscribe to a single service and use the same software suite throughout the entire organization. Utility computing is also compatible, which is especially needed in large companies that having many departments. Each department could be using a different software suite, which makes the files from one department to be incompatible with the software used by another department. Through the utility computing, a single service can be used throughout and the same software suite is used across the department. Now, the disadvantages. Limited access to the vendor facilities and resources, reluctance and refusal of vendors to discuss how they handle customer needs, reluctance or refusal of vendors to conduct disaster recovery tests of client resources, theft of customer data by rogue vendor employees, collocations of customer systems and data with other customers. Now, the application of utility computing. Applications are cloud computing, SaaS, data storage, disaster recovery, and high performance computing. Cloud computing provides scalable resource like storage and processing on demand. Then SaaS, software as a service, delivers software over the internet on a subscription basis. Data storage offers scalable storage solution with pay as you go pricing. Disaster recovery provides backup and recovery services to the handle data loss. High performance computing offers computational power for intensive tasks on a pay as you basis. Cloud computing. Cloud computing is a method of utilizing on-demand computer services via the internet. There is no need to maintain the physical service. Instead, service providers such as AWS, Google Cloud Platform provide user with the necessary storage, database, software, and networking. There are three types of cloud computing services: infrastructure as a service, software as a service, and platform as a service. Here is the representation of cloud computing and the architecture of the cloud computing. Application. The cloud computing applications. Storage and backup. Storing and backup data in secure, accessible manner. Software as a service. Providing the software applications over the internet. Big data analytics. Processing and analyzing large data sets to extract insights. Internet of Things, IoT. Connecting and managing IoT devices. And the disaster recovery. Now we are discussing the cloud deployment models. Public cloud, private cloud, hybrid cloud, and there is other clouds like community cloud, but mainly the public cloud, private cloud, and the hybrid cloud. Public clouds that are owned and operated by a third party cloud service provider, and it can be accessible by everyone. The private cloud. A private cloud refers to the cloud computing resources used exclusively by a single business or organization. A private cloud can be physically located on the company's on-site data center. Some companies also pay third-party services providers to host their private cloud. Hybrid cloud. Hybrid clouds combine public and private clouds bound together by technology that allows data and application to be shared between them. By allowing data and application to be moved between private and public clouds, a hybrid cloud gives you business greater flexibility and more deployment options and helps to optimize our existing infrastructure, security, and compliance. Now, the cloud service models. First, infrastructure as a service, then platform as a service, then software as a service. Now, infrastructure as a service provides virtualized computing resources, operating systems, applications, data, and the infrastructure configuration. Highly scalable. Security is the users responsible, and the examples are AWS, Microsoft Azure, Google Compute Engine. Platform as a service. Complete development and deployment environment. It's mainly used by the developers and the someone that are using coding. Then they are highly scalable. Examples are Google App Engine, Microsoft Azure App Service. Then software as a service. It's cloud-based software applications. User controls only the data. Low scalability, and the security is also the provider's responsibility. But in the case of infrastructure as a service, the security is the responsibility of user. And in platform as a service, a PaaS, applications, data, and some other platform configurations can be controlled by user. Please remember these points, it's very important. The cloud service models. Edge computing. Edge computing is a network philosophy focused on bringing computing as close to the source of data as possible in order to reduce latency and bandwidth use. In simpler terms, edge computing means running fewer processes in the cloud and moving those processes to local places such as on a user's computer, an IoT device, or an edge server. Bringing computation to the network edge minimizes the amount of long-distance communication that has to happen between a client and server. Here is a representation of edge computing. And some possible use cases of edge computing. IoT devices, self-driving cars, more efficient caching, medical monitoring devices, and security system monitoring. IoT devices, smart devices that connect to the internet can benefit from running code on devices itself rather than in the cloud for more efficient user interaction. Self-driving cars, autonomous vehicles need to react in real time without waiting for instruction from a server. Medical monitoring devices. It is crucial for medical devices to respond in real time without waiting to hear from a cloud server. Pros and cons of edge computing, or the advantages and disadvantages. Advantages: low latency, reduced bandwidth, improved data security and privacy, offline functionality, decentralized infrastructure. Now, the disadvantages: limited resources, higher upfront cost, security management challenges, software compatibility issues, and the limited scalability. Peer-to-peer computing, or the P2P computing. The P2P computing architecture contains nodes that are equal participants in data sharing. All the tasks are equally divided between all the nodes. The nodes interact with each other as required as share resources. Characteristics of the peer-to-peer computing. Peer-to-peer computing networks are usually formed by groups of a dozen or less computers. These computers all store their data using individual security but also share data with all other nodes. The nodes in the peer-to-peer networks both use resources and provide resources. So if the nodes increases, then the resource sharing capacity of the peer-to-peer network also increases. Now, the advantages of peer-to-peer computing. Each computer in the peer-to-peer networks manages itself, so the network is quite easy to set up and maintain. In the client-server network, the server handles all the requests of the clients. This provision is not required in peer-to-peer computing and the cost of the server is saved. It is easy to scale the peer-to-peer network and add more nodes. This only increases the data sharing capacity of the system. None of the nodes in the peer-to-peer network are dependent on the other for their functioning. Now the disadvantages. It is difficult to back up the data as it is stored in different computer systems and there is no central server. It is difficult to provide overall security in the peer-to-peer network as each system is independent and contains its own data. Some applications of P2P network or P2P computing. Applications. File sharing. Sharing files directly between users without a central server. Decentralized marketplace. P2P based marketplaces connecting buyers and sellers directly. Decentralized storage. P2P based storage solutions providing secure and redundant data storage. Now, the comparisons between different computing paradigms or the key differences between the different paradigms which we discussed in this video. First, the cloud computing, centralized management, scalable resources, pay per use model, internet dependent, suitable for large scale applications, and data storage processing. Now, the edge computing, decentralized processing, real time processing, reduced latency, internet independent, more suitable for IoT and real time analytics. The grid computing, coordinated resources sharing, high performance computing, collaborative research and development, suitable for scientific simulations and data analytics. Now the P2P computing, decentralized and having equal rights to the data, direct resources sharing, no central authority, suitable for file sharing and decentralized application and social networks. Distributed computing, breaking tasks into smaller parts, processing across multiple devices, suitable for large scale applications and data processing and simulation. The fog computing. Fog computing is a distributed processing environment, intermediate processing between cloud and edge, reduces latency and bandwidth usage, suitable for industrial automation, smart cities, and applications requiring intermediate processing. Fog computing is used in the IoT, Internet of Things. Now, the mobile computing and quantum computing. Mobile computing, it's portable and wireless computing. It can access from anywhere at any time, suitable for personal devices, fieldwork and remote access. Quantum computing, mechanical phenomena based processing, simulations, optimization and cryptography, more suitable for complex problem solving and scientific researches and cryptography. Hope all of you got an idea about different computing paradigms. Thank you.